Good afternoon, my name is Lino González. I am a research and PhD candidate at University of Alcalá. Now I want to present the paper Entity Linkages and Population Mechanisms for Skill Ontologies, evaluating the use of ESCO and Wikidata. This research has been carried out jointly with Professor Miguel-Angel Sicilia and Elena Garcia, whom I would like to thank for their great support. Competence or skill databases and knowledge bases are an important component for different applications, for example, training or human resources. Nowadays, new competencies and skills are created very quickly, and it is very difficult to have updated these databases. Through this research, we want to solve this problem. Using non-occupational knowledge bases available openly as Wikipedia to update the competencies of these databases. In this paper, we have used as a basis the European Skills, Competencies, Qualification and Occupation Ontology ESCO, to which we have added new related content obtained from Wikidata through entity linking. The method for linking skills consisted on 3 steps: entity recognition, entity linking, extraction candidate entities. Next, we will see in more detail each one of these steps. To do the entity recognition, we have used the Spaces pre-trained NER model. This model is based on state-of-the-art neural models that uses convolutional networks and built on glove vectors. The NER F-score reported in Spaces documentation is 85.36. The documents for the matching were the result of the concatenation of the fields preferred label, description, and alt labels found in the file containing the skills obtained from the ESCO website in English language. Only skills of ESCO type knowledge were used for the matching, since the departure assumption is that names of concrete entities appear in that kind of ESCO resources. A file with the matchings was produced, including information on the match skill and the text and the type on the entity identity. Finally, a manual filtration was performed to remove the erroneously recognized entities. In the entity recognition process, we use 13,485 documents for ESCO. And after running the Spaces pre-trained NER model, we got 2,520 matches over 962 different skills. Of these matches, 51% correspond to entity about organization, 14% correspond to entity about nationalities, religions, or political group, 7% correspond to entity about person, and the rest correspond to another type of entities. Entity linking was carried out by disambiguation of entities in the large Wikibase knowledge graph. We use SPARQL queries that match the string of the terms found. We look for entities whose descriptions are similar to the preferred label and description fields, extracted from ESCO. The manual inspection of the result showed correct matches for around 50% of the distinct entities relevance coming from the NER process. We will go through the Wikidata graph to find entities related to the entities detected in the previous point. We can use the new entities found to automatically improve the ESCO skill model. Although the semantic inconsistencies in Wikidata hamper the possibility of doing the process automatically. We have reported the use of pre-trained language model for the task of linking entities from the ESCO database of skills to Wikidata, for the specific purpose of extracting potential additional knowledge items to ESCO. The performance of state-of-the-art pre-trained models produce a small set of relevant matches for the use case that had to be manually filtered. Space's pre-trained NER model is very generalist, and it will be interesting to use a specific trained model for the identification of competencies and skills. The inspection of the entities currently linked to an entity creates new knowledge graph from which we can extract new items that we can add to the ESCO skill model. For example, here we have the knowledge graph created from the entity Haskell, and we could follow the linking of the graph to continue finding new related entities. The problem now is to identify which entities found are relevant to the ESCO skill model. There is also a big quality problem in the results obtained from extracting entities from Wikidata. This also requires some kind of quality control on the entities being extracted. Since each crowdsourced naturally entails a degree of errors that prevent the direct inclusion of new knowledge items. Improving these points, we consider this method as a promising mechanism to keep the skill database updated. The inspection of the entities currently linked to an entity creates new knowledge graph from which we can extract new items that we can add to the ESCO skill model. For example, here we have the knowledge graph created from the entity Haskell, and we could follow the linking of the graph to continue finding new related entities. The problem now is to identify which entities found are relevant to the ESCO skill model. Thank you for your attention, and I hope the presentation was of interest to you. Greetings to all.